Hi. Uh, I'm late and I'm sorry, but I was home this past weekend. But nevertheless, I still wanted to talk about my week 3 project, which I did end up completing for the Alphabet Superset. And so, yeah, rather than going through a whole editing process, I thought I'd just make a quick video. So that way, I still kind of get it out in a reasonable time as well as, you know, continue with the process. And so, yeah, this week was week C. And C this week stood for compliant mechanisms. So this is actually a big engineering topic that I was interested in, and still am, of course, and something that I actually kind of want to continue working on because I don't think I really finished this project entirely, but I got it to a point where technically the function and definition of it fits with this design. However, I want to do something where I can actually keep it in a certain state, which I'll explain later. So to kind of get into detail about a compliant mechanism, pretty much it's where you have a structure that you can elastically deform. Elastic meaning you can, bend or, stretch it out and it will recover back. So think of, for example, like a spring, you can elastically deform it and it'll come back. Whereas plastic, if you were to, bend the spring a certain way, and it doesn't recover back, that would be the plastic deformation. You kind of break the structure for it. And so, pretty much anyway, elastic deformation of the structure creates a motion or a kind of like a force output in the system. And because it's all in like one piece, and it's you can do really unique designs nowadays. Compliant mechanisms really transform the elastic deformation into a way that can potentially mimic and pretty much perform the same functions that multiple parts were meant to do, or things that you know took a lot of pieces or um, needed some way to get a degree of motion introduced into the system. You can actually do this through additive manufacturing designing through like 3D printing or new machining abilities that allow it to become more effective now to just make one piece and just manipulate it through elastic deformation. And so, yeah, compliant mechanisms are really cool. It's a really fun way to kind of like get into, how strong and materials are and how pliant they can be. Heck, you can think of like backpack clips. Let me find a backpack clip. I have one somewhere. Where's my camera bag? Oh, here we go. Yeah. So like, I mean, technically, this is a compliant system when you think about it. Oh my gosh, gotta be careful with my camera. Um, you can see that the this piece here, right? We're deforming this and then pushing it in, so it bends in and then locks in place because it bends and relaxes back. So that motion of being able to, um, you know, put it in and lock it and then push it back. That's it's compliant. It's elastic to be able to lock and keep your bag as one whole strap. So anyway, sorry, I know this is rambling, but yeah, compliant mechanisms, cool stuff. Really want to delve deeper into them for sure down the line. Anyway, for my keychain, I decided to do a compliant mechanism, and I was at first gonna try to make like the pliers that BYU has popularly done with 3D printed compliant mechanisms. But I ended up looking at some other examples and kind of got influenced by their bistable mechanism. Pretty much, it's like think of like the Green lantern going down and up, but being able to lock in place. It has like a nice, satisfying snap. So I'm like, oh, maybe I can try to do that. And so I was just kind of tinkering around, and yeah, I went through like 4 iterations, and I might go through more down the line. But yeah, this is design one. This is the um, yeah, this is the first design, and so pretty much you can see that there's these 4 beams here, and what this would do is that they can bend downward, and it kind of mimics like a sun setting onto a mountain. That was kind of like the artistic idea I was inspired to do as I was working on this. At first it was like a circle, and I'm like, oh, maybe we can do a like a sunset. So yeah, that's the whole thing here. you can see that, I'm bending this down. It's doing, a straight linear motion downward toward the mountain peak, and then recovering back. I can press hard, and it's still recovering back. So it's still elastic. So, compliant mechanism. Compliant mechanism. Doesn't lock, but compliant, Still works. Still fits that theme. Then I'm like, I want to make this work. But we'll see. So I ended up doing a two-prong design. But the issue here was that this is actually very plastic. You can kind of see already it's a little bit warped. But you can press down. It doesn't really recover that well. You can see it kind of like angling out here. And then, lifting it up. It's just, it wasn't that good. I was like, okay, maybe I don't want to mess with splines. But rather, I'll try to mimic more of the bistaple mechanism's design. And so I ended up with this third iteration here. And you can see that, still linear, still kind of does that things, but it doesn't lock. And I was thinking, okay, maybe it's because of how this length here and like the shorter lengths here don't match, or this is a longer beam, so the forces aren't really keeping things locked. And so I made another one where I just kind of copied the legs, and the motion's a bit better, for sure. Definitely still compliant, but I don't know, just didn't work how I wanted it to. But then I noticed that I was missing a feature compared to the bistaple mechanism, where there's like thin strands as well, so that it would probably store the deformation. So I might try to work on this design a bit. Maybe I can do it down the line. It's not a priority, but it's more of like I want to get a nice compliant mechanism going. So yeah, we'll see how it goes. But nevertheless, while I didn't get it like entirely right for my dream function, the fact that it was like the first time I did a compliant mechanism with intent, and not to mention, I kind of got to see, this is, the thickness of a single 3D printing filament strand. These legs here. And so it kind of just goes to show, actually, this one's 2 layers. This one's 1 layer, the thin pieces here. So it kind of just goes to show that, stacking these layers up X amount, it shows how strong, like, even PLA, one of the weaker plastics, is. And so it's really cool. Really kind of showed me the strength of 3D printing, mechanically speaking, of course. And so, yeah, really happy how that turned out. By the way, for some reason, my recording software has been freezing a lot, so since I'm not going to be editing this, you're going to notice that. I don't know. So yeah. But anyway, that's pretty much it. Those were all the models, and yeah, I didn't get a chance to be able to do something at home, like recording a video, so I just thought I'd do it here, right now, after work. That's why I'm a bit of a mess. But yeah, anywho, next week is Engineering Project D, Keychain D. So we'll see where that goes. Not really sure what project I'm going to do yet. I'm probably going to look at the idea list that I made a while back, as well as maybe just kind of Google different mechanisms. But yeah, I'm pretty sure we'll find something, and we'll design it, and I'll be probably around this weekend, so I'll probably edit it. Or not. We'll see. I don't know. Either way, we're designing still. It's fun. I've been enjoying the process. This one especially, I like this. So, 3 weeks in, and we're still having fun. We're still trying our best. So, yeah. Anywho, that's my update. I hope you have a great rest of your day and a great week. To those doing the Alphabet Superset, enjoy week D. And lastly, I'll see you later. D's! I should have... Bye.